Hello and welcome to yet another video. What we have for you today is something different than what we are usually doing. We thought about having a chat related to the practices that would help programmers today. And I think some of these practices are different for junior programmers, for medium, for senior programmers. So let's see how far we'll go. I don't know exactly, since this is completely unscripted, and we'll just be building together a list of practices that we think is useful. And as usually, with me today is Adi. Hi, Adi.
Hello.
Now, Adi is somewhere secret, so his internet is not that good, right?
Yes, and my laptop is not what it usually is, so I hope we'll be fine.
So if the image freezes, that's why, but we'll still be able to hear him. All right, so today, let's start with junior programmers, and let's think about some of the practices that are helpful. And maybe before we start, let's just discuss a bit why we are talking about practices and not about tools or other things. Why do you think practices are important?
Well, because with good practice, you don't understand what tools you need. It's the same as I like to do a lot of, let's say, physical type of work, like let's say carpentry or gardening. Once you start knowing what you need to do, you start understanding what tools you need. So that's why probably you start off with some tools, whatever you found out, you read on the internet, maybe a colleague told you, or a professor in university told you, or something like that. And then you start understanding if that tool is useful for you while you acquire more knowledge. So that's why practice is important. And I think you have at least two ways to get better at what you're doing: to work more in a commercial way, or to practice more in a non-commercial way. So in a way to, let's say, try to play or try to have a pet project and so on, or try to do something to be better, so to learn more. And that's why I think tools are there to help you.
Right. So, and this maps a lot with my experience when I was just starting as a developer. My focus was it was C++ back then. So my focus was on writing C++ code that worked. And I would say that this was most of my focus, because it was very difficult to make C++ code work. And in particular, to make code work consistently and over long periods of time, right? So with little mistakes. But then as I moved along, I discovered, okay, so you write code and you keep adding to an application, and the application grows, and then you get a code base, and then suddenly you need to figure out how to organize that code base. And no tool tells you how to organize your code base. I mean, there are some frameworks, they tell you MVC or whatever, but what does that mean for your particular code base? No idea. This is already one thing that you need to learn. And then as things progressed, I ended up years later learning, well, first unit testing, test first programming, and later test-driven development, which allowed me to, without thinking about the structure beforehand, to actually have this structure incrementally, build it incrementally. And right, so this is this is what you can see. And then what's interesting is that you can translate these practices into any technology. Even AI
Exactly.
will need to be tested, games need to be tested. So if you're doing a different type of application, there are perhaps different ways in which you'll do that, most likely, but you'll still have the practices. So those become kind of constant. And we discussed this a bit when we talked about polyglot programming, that when you have the toolbox of practices, then you can take them to no matter technology you're using. You're doing C++ for embedded software, fine. You have different tools. Practices are the same. You're doing web applications in Node.js, fine. Same practices, different tools. So nothing is really... I guess these are the constants that you'll take with you in whatever technology you're dealing with, right? So let's see, what do we think would help junior programmers? And I would like to start with one. I don't like this, I'll just pull a shape. And I would say command line. Command line is very, very important. Because once again, command line is something that you can translate. And what's interesting today is that you have a version of Linux running on Windows, running on Mac OS, and of course on Linux. So what I would say, learn the Linux command line. This will be extremely useful.
Yes, it's true. I think command line used to be very common, but we have more and more things attached to the IDEs. So then more and more is graphical user interface. And then junior programmers, but I think most of all, let's say, programmers start to be used to this UI, and less with command line. But even with some of the best tools, I found mistakes in those user interfaces, and I tend not to trust them unless it's something that really works and has worked really well. That's why command line is more reliable, translatable, as you said, and easier to find, because if you don't have your add-on, your preferred add-on on I don't know which IDE, then you won't be able to work, whereas command line is everywhere. So,
and let me give you also another use case. You are leaving home, it's like late in the afternoon, you want to leave home, but suddenly there's an issue in production, and you are the one who has to deal with it, right? And you need to get some kind of information from the servers. Guess what? Servers don't have graphical user interfaces, and typically it's very difficult. It's possible with some IDEs, but it's very difficult to connect. So best way still to this day is SSH there, and then use command line to search through log files, or Vim to change configurations or stuff like that. So because these are the universal things, you'll find them anywhere. It's one particular note here is Git. I actually saw recently a question on Quora. Why do so many programmers use Git from the command line instead of using the graphical user interface? So just a quick aside, because Git is one of the tools. But generally, I think you should only know a few commands in Git. Git init, git add, git commit, git branch, git merge, or if you really want to, it's rebase, I think. And for more advanced people, Bisect. If you want to search for if you want to debug a specific issue. These are all the commands you'll know. No force, no fancy things, right? These are the ones that you should know. And that's all. Don't if you find yourself in a situation where you need to force things in Git, then it's already a bad situation. And this is why I prefer to write these commands. Git diff. Okay, let's add another one, maybe. When I use these from command line, it's much faster for me.
Yeah, but you need to write all that stuff all over and over again.
Oh, and this is a good thing. Let's talk about the controversial one. Touch typing. So I was doing a talk once about software craft practices, and I mentioned touch typing as being one of the fundamental skills that you need to have, and not necessarily because programming is about typing. I mean, if you type faster, you don't necessarily program faster. But this is what it's helpful for. When you type without paying attention to what you're typing, your hands are just moving, then you get the ability of focusing on higher order concepts. So you are no longer thinking about, oh, I need to type T and H and all these things. What you are thinking is, okay, we need a conditional here. You have the conditional, and so on. So it frees up part of your mind. That's the basic idea with touch typing. Yet somebody told me after this, and they were very, very annoyed, that this is like tailor management because we are optimizing for typing and so on. And no, we're not doing that. It still pains me to see programmers looking at their keyboards while typing code. It actually hurts me.
Yeah, it's like you're not using the full potential, and in a way you are like driving with the brake on, because you could do much more, but there's this typing thing keeping you away from something a lot greater that you could achieve. And it's not something difficult to do, I think. With a bit of practice, you can easily get to something that's okay. And if you want to get really good, then okay, you need some work, but it's not that difficult.
Yeah, so just to make sure, the goal here is not to type, I don't know what would be a very fast, 200 words per minute or something like that.
Yes.
I think that's the...
More than 150, I think it's not, it's way too optimized, let's say. You know, it's not bringing any more benefits.
Yeah. So that is just for very specific situations, like if you are translating in real time speeches at the General Assembly of UN or something like that. But we are not doing that. The goal is not necessarily to type fast. The goal would be to free your mind from the actual effort of figuring out where to go with your fingers. So if you have your fingers moving by themselves to the right keys, and you always keep your eyes on the code instead of on the keyboard, then I'd say it's pretty good. Now, if you can also improve a bit so that you don't make mistakes while typing, even better. Right? But that's what we are trying to do. So not a lot of optimization here, right? Because typing is not the bottleneck of programming. But programming is such a job that demands so much from your brain that you actually need to free up capacity to make sure that you can work effectively and you can focus on the right issues. Okay, and I think I said we won't be talking about tools, but it's probably important to mention this. I guess it's a practice. Know your editor.
Yes.
Or IDE. So once again, as a practice, I don't actually care too much which IDE or editor you're using. Maybe you're using Visual Studio Code or Visual Studio or IntelliJ or some other JetBrains one. Or maybe you are like me in the past years using Vim and with some plugins and stuff like that. Or maybe you love Emacs. Fine. Whichever one you're using doesn't matter. But what I would like you to know, not what I would like you, but what would help you to know is a few things. Shortcuts in your editor. So once again about keyboard, and combine this with touch typing, it can be a very powerful thing. So imagine things like move a method from one file to another.
Yeah, or renaming multiple things at once, or even generating new files, generating methods, or some sort of snippets for generating code that are repeatedly, like, I don't know, getters, setters, whatever, something like that. Yeah. All these are useful.
So a few things that you might find in your editor and that you don't know exist. Duplicate line. Very useful sometimes. Move line. You can typically move a line up and down and so on. Move block. Or you select something and you can move it up, down, things like that. Then of course refactoring. But I think we'll talk about this in a little while. Generation of snippets. And I would add a very, very cool feature that I'm not sure many people know exists, which is Smart Clipboard. So Smart Clipboard, I've done this again and again, right? You need to modify a piece of code, but you need to copy and paste 3 different things. Okay, so how would you do that? You first need to copy from one file, switch to the other file, paste there. Copy to switch to the other file, paste, and so on. And if you are making a mistake, for example, you don't forget to paste and you copy, oh, it's overwritten your initial thing, and it's very annoying. You need to go back and start from the beginning. Well, turns out there are these things in Linux. You can actually install them as an OS thing. In many IDEs, you have them built in. So a smart clipboard will remember the last things that you copied. So not only the last one, but the last ones. So maybe you'd have 5 or 10 things, and then you can go back and copy them again with one keyboard shortcut or one click of the mouse, instead of going back, copying, pasting again. So extremely helpful. Once again, it helps you. Knowing your editor helps in the same way as touch typing helps. You could probably go around with using your editor like a notepad. It would be fine. Like the simplest editor, But the problem is, if you know, or actually the opportunity is, if you know how to do these things, and you start thinking in operations, instead of thinking in just simple primitives, writing things, copy pasting and things like that, then suddenly you'll be faster. You'll be able to try out more things faster. And I will just write here in the middle, because this is something important. Experiment. Particularly for junior developers. I often get the question from people who will join the workforce soon. Should I learn Java or C++? Which one is better for?
Yes. For what?
For my career. Which will,
yes.
I mean, the question is, I guess, which one would help me get hired, get more money, grow in my career and so on. And my answer is both. I mean, to me, it's a very strange question, because I always learned as much as I could about software development. And I think the key is, if you were to ask me, don't focus on what programming language should you know. Experiment. Figure out ways to experiment with different programming languages. But at the same time, master at least one programming language. Right?
Yeah, and I guess in time, what I saw is that if you learn a programming language that's more object-oriented, and then you learn some programming language that's more functional, that's kind of everything you need to get to understand all the other languages. Of course, there are like special languages, and you need to understand there's really complex ideas sometimes if we refer to C++ or Go or some other languages, or C even. But still, if you have used to the broader extent, if you have used an object-oriented language and one that's more focused on functional program or functional paradigm, then you can learn anything after that.
Yeah.
So I think that would be the idea. If you started off with one of the two categories, try then to learn the other one.
Yeah. And I would add, So one object-oriented, one functional. And this is a different category, but I think it's important. One with loose typing.
Yes.
One with strong typing, one with loose typing.
Category.
Yeah. Because they are different. You will look at programming differently. But you need to master one. Pick one, master it, understand it. C++ is a really good language to master. It might take you a very long time, but if you can write, one advantage of C++ is that you can use it to write all the different paradigms of software. So you can write functional, you can write object-oriented, you can run procedural, you can write very strong types, meta programming, systems programming, and so on. So it is very interesting how you can do that, but because it's so flexible, let's say, it's also quite costly to learn all these things. So yeah, be aware of that. But C++, yeah, it's a very good language to learn, because once you understand how memory management works in C++, then you'll understand how memory management works in any programming language. And this is very, very powerful when you need to do performance or when weird things happen in your C# code or in your Java code. Sometimes it's because of this. All right.
Yeah, and I would add here just one thing on programming language, that learning a programming language and master it, as you said, doesn't mean that you know all the libraries by heart.
Yeah.
I saw that I was part of some interviews with junior programmers, and apparently some of them consider that's the idea, that you should know exactly how to do parse string, or how to do I don't know what type of computation, and that's not the idea. That's why we have documentation. The idea is that you should know how the language works and what it can do, what are maybe the better approaches or structures for a certain problem, and then for the details you always have documentation. I was even reading on Twitter a few weeks back, like there was a conversation with many very experienced programmers, and almost all of them said that they always look up on Google, or they look up the documentation for details, even after 20-30 years of experience, because that's what you need to do. It doesn't make sense to remember all the details.
Yeah, absolutely. No matter how long you are programming, you will still need to Google things, or Stack Overflow in the worst case. But yeah. But this actually brings to an interesting thing, which is tooling around the programming language. No matter what programming language you are learning, you should know, as Adi said, the fundamentals. So how does that work? How does memory management work? How do you know what you can do with it and all that? But I think there's another area which is very interesting, and it's about things like how to package a program. So you've written a program in C++. How do you create a deployable package? Right? What are the options here? You've done one in Java, you've done one in Python. No, how do you deploy those? Then there's more and more the advent of virtual environments, or so something like in Python you can have multiple Python versions side by side, and I could have one program that uses Python 2.7 and another one that uses Python 3.10, But also, what this brings is dependency management. Almost every program will need to use some external libraries. So let's say if I'm doing a C++ program, but I need to read from a CSV file and to create a zip at the end. I probably can already use 2 libraries for that. How do I deal with these dependencies? So let's say I create this project on my computer, but then how do I make sure that other people can actually recreate the same thing? And this is where you have dependency management. Other things that are interesting, how do we write unit tests? What libraries do we need? And it can be, okay, there are many, many different libraries from almost any programming language. Yeah. Just the most common one, the one that is most easy to find and use, the one that comes at when you are searching on Google, first one that comes when you're asking unit testing in. So these are a few things that I think are useful, no matter what programming language you use, besides the actual language. Okay, what else? Should we mention refactoring? Or maybe before?
I don't know if I would. I wouldn't go with refactoring for junior programmer. I would. Maybe my preference would be something a little bit that might sound strange, and I often see that we have a lack of analysis skills.
Mm-hmm.
So what does that mean, analysis skills? It means that when you look at the problem, to try to structure in a way what options of solutions you have. To understand, first of all, to analyze, to understand the problem, and then to understand what solutions you might find and then discuss openly about those. And I find that there's maybe more and more lack of this analysis skills. It's a skill set. And it also comes with a set of questions that you need to ask, or a set of questions you need to ask yourself and look up in the documentation so that you understand what you need to do. So I find this extremely useful, and it brings a junior programmer to a totally different level in a team. A junior programmer who has these skills in a team will be regarded very well. We will have much more support, I think, from everyone, or even from the whoever is requesting the has the requirements and so on.
Mm-hmm. Yeah, that makes a lot of sense, and there's still a bit of a challenge here. So there's a big difference between the way you learn programming at school and the way it actually happens. And the big difference is that in a school you'll get, this is the problem, find the solution. Right. And maybe there are some variations to the solution, but there isn't such a large solution space. Right? I mean, you usually know that you need to use some kind of, it's pretty constrained. In real world, the problem does not come such neatly defined.
Mm-hmm.
So you need first to figure out what the problem is, and then the solution space is very large. And this is a big challenge here.
So the biggest issue I find is understanding what the problem is.
Yeah.
In fact, sounds really weird. Maybe you know, if someone who's now in university and who's listening to us and wants to become a professional programmer would think that's a very weird thing to say. But in real life, sometimes something happens and you need to understand why.
Yeah.
So you need to understand the problem. And that's the more you have a mature product or a product that is really used by people, the more you have these situations.
Yeah. Yeah, so sometimes a user will complain that, or will have a need for a feature, and they will tell you, oh, I need X feature. If you start implementing that feature, it might cost you a lot, and then you might figure out that it's not actually what the user wanted. Or it only helps that one specific user. And this is a big problem. So instead, when you receive such a request, you need to figure out, okay, what is the problem behind the problem? And there's this type of analysis that's a bit difficult to do. Any ideas on some practical ways to improve these skills?
I think the best way to go to this, there's some very typical approaches like the root cause analysis, 5 whys. These are some tools that maybe don't have anything to do with programming on the first view. They come more from management, but they could be useful. Or there's also the solutions from the CIA handbook on
the Phoenix checklist. Yeah.
Yes, exactly. On where they analyze what CIA is doing. So that's very useful, I think, as well. There are all sorts of things like this. Maybe even the idea of having a checklist to ask certain questions is good. To ask questions so that you don't forget to put some questions or some types of questions. So I think there's a very approach, but all of them go to the same area.
What I would advise is to focus on an example and draw a diagram, or use BDD example mapping. So there's a big power in examples, which, by the way, is lost again on people in universities, because in universities the questions, even the projects that we are doing, they are not that difficult. And when you don't know what the problem is, one way to do it is to just start from a very concrete example. So if you are dealing with some users doing some things, give names to those users and say, Alice does something, Bob does something. Make it very, very concrete. So if you take the example of, getting a credit from a bank, you'd have Alice that goes to the bank and asks for a credit, and the value of the credit is 50,000 euros. So very, very concrete, just down to the numbers, to the actual examples. And it doesn't matter if it's the most common case, don't worry about that, just pick one. Because once you have one that is clear, then you can think of variations. They say, okay, so what happens if they want 100,000 euros? What happens if they want 10,000 euros? What happens if they only want €1? And so on. So this is a way to understanding the problem, and it's a very good analysis technique as a junior programmer when you don't understand precisely what the task is. Which reminds me of something else which we should write here. Always ask questions.
Yes. That's a big problem, I think, that I saw from many areas and many people. The fact that we rush into the solution without understanding the problem because we don't ask enough questions.
Yeah, sometimes it's because we want to do a good job and we feel like we are wasting somebody's time by asking questions. But guess what? If you start implementing something and you get stuck, then you will be wasting somebody's time. Actually, everybody's time, all the team's time. If you don't get stuck but implement something that's wrong, you will still be wasting time. So don't worry, just ask the questions. If you have something that's not completely clear, because the thing is, your job is to take some vague requirements and turn them into very precise code. You cannot do that unless you understand. You take those requirements and make them very precise. And part of it is asking questions. It's right. And if you get stuck, that's another practice, really good one. When stuck, ask for help.
Yeah, and stuck as a note doesn't mean that I've been trying for 5 days and then I ask for help. And stuck means maybe a few hours.
1 hour, let's say.
Yeah.
2 hours. Let's say 2 hours. Okay, for 2 hours.
Exactly. So something like that, because I saw that happening with junior programmers trying to do something and they get stuck and then they say, I don't know what to do. But well, when did you get stuck? 3 days ago. Why didn't you ask? So that's not the way to go.
And this is linked in a way with another thing, commit often. Now, I'm not sure this is a skill that you can master as a junior programmer, but it is a good habit to start forming. You have something working, commit. Figure out what's the next thing that you want to make work, make it work. Once it's working, commit. It doesn't matter. So here's a hint. You can commit, let's take the Git example. Let's say if we commit every 5 minutes, we get how many? 12 commits per hour. 12 times, let's say 5, about 60 commits per day. I doubt you'll get that far, but let's say you get 60 commits per day.
That would be good.
That would be good, but I don't think it will happen. If you do that and you have a mistake, the worst thing you can do is go back 5 minutes in time. Or maybe 10 minutes or maybe 1 hour. Right? Not that hard. And this is where Git Bisect is very useful, by the way. You can figure out on which commit you actually made the mistake. But then you will say, okay, but then I have to merge these, and in order to merge these, it will be a big mess because there's a lot of commits. Don't worry. in Git you can actually I don't know the actual term, but you can actually collapse multiple commits into one. So commit often when you are sure things work. You can collapse into one, merge that one, and you're done. As easy as that. All right. Anything else?
I think we have a pretty good list. I would add just something that's more generic thing, or two things, more or less. Be open, first of all, to whatever suggestions come to you. And second of all, don't be afraid. Because anyway, you're learning, and I guess when you learn, you do mistakes, you may ask questions that might sound stupid, but there is no such thing. So
I'm always making mistakes.
Yes,
I'm
those two things are very important.
Yeah. I would also add some kind of notion of code guidelines. Maybe let's just make it easier. Okay, so follow the code guidelines, coding guidelines. But perhaps the most important one that I would like you to, and that will help you a lot, is focus on writing names that are precise and meaningful, or focus on using names that are precise and meaningful. And I know
which is a skill in itself, indeed, and you need to, it takes a bit of time to get used to this idea.
Yeah, and this is why I said focus. It's not mastery. It's something that you will need to practice for a long time. But here's where it helps. You can write code that is working if you pay attention. But it's harder to write code that can be modified later on by your colleagues, by you. And so imagine when you are writing the code, and perhaps this is another thing that we should add. I like to use a mantra. First, make things work. Well, I guess it would be first understand the problem. Right? Then make things work according to the description of the problem. Then clean. Oops, it was syncing. Then clean it up. And by cleaning it up, in this case, do some renames. Just do that. Rename things. If you use the variable that's called, which is one that I like, TMP, MGR, manager, figure out a better name. What is it managing? What is, start asking a few questions. And don't be afraid of writing longer names. It's okay. Write longer names if necessary. So in this case, rename. Okay. Then measure. Only when needed, improve performance. Now this mantra does not work for everything. It would be a mantra for changeable code. Right. Perhaps if you are writing a real-time system that is self-driving an airplane, you need to focus on performance first. Right. But if you're doing a web application, you can leave the performance a bit later. It's fine. It's okay. So try to focus on this. Make things work, rename, and leave the performance for later on. Okay, so and if you learn how to use the names, oh, and here's a hint for names. Hint. Ask domain experts what terms they use. And I guess this should be here with a general attitude. Have coffee with people. And ask questions. Like if you find domain experts, maybe you have some in your organization when you're working. Have a coffee with them and ask them, oh, I saw that term. What does it mean?
Exactly.
Okay. All right. So I think we have a good set of things here. It's a nice map. I kind of like it. Anything you'd like to say in the conclusion?
I don't know. I think we covered a lot of things. I think the most important thing is to keep going and keep learning, keep asking questions, be open, and everything will be fine.
Yeah, that's it. And I would add to this, practice skills. If you find that something is slowing you down, either because you realize or because somebody else is telling you that that thing is slowing you down, the best way to deal with that is practice. We can also help with that, but there are also resources on deliberate practice of various things, and that's what I would advise you. All right, this is it for today. We thought about doing this as I say, since we are getting close to the end of the YouTube season for us, and we'll take a holiday in which we will still have videos, but we know many of our audience members are also gonna be in holidays, and they watch fewer content and fewer videos. We'll still have a series on if I'm able to edit it in time, on Alex Learns HTMX. HTMX is a really neat solution for implementing rich web applications, those things with Ajax and so on, but without using any weird framework, any complex framework. We are just using attributes in HTML, and it's really cool. I love it. But I have a bunch of videos that I need to edit, so we'll see how well that goes. So this is the plan. And then I think in autumn, what we'll try to do when we restart is to start with a bang and do a live show. That would be cool. And it would be really cool to have you. We have 400 subscribers now, which is great. And having you with us will be even better, because then we can actually chat a bit and figure out, you know, what kind of things you'd like to learn. And maybe you have some questions for us that you didn't want to ask in comments, and let's see, maybe we can make this happen. I guess sometime in the beginning of September. So this is it for today. Subscribe to this channel if you enjoyed it. Like, share, tell other people about it. And tell us in the comments if you have ideas about other things that we should talk about. Are these skills useful? Is this map useful for you? If it is, great. If not, what it's missing? What are some of the questions that we haven't answered here? Let us know, and we'll make sure to add some more details and make other videos. Thank you so much for watching, and until next time, remember to think, design, and work smart.